Bismillahirrahmanirrahim. Assalamualaikum and very good morning. Okay, today we are going to discuss about IPv4 addressing. IP has two versions. Okay, one is version 4 and another one is version 6. Okay, IP version 4 is very important. It's very important nowadays because the internet is running on version 4. Okay, so IP version 4 is already it's already been established, so that our internet nowadays can be implemented by using this version. Okay, so in this chapter, I'm going to give a brief introduction about IPv4, and then I'm going to explain about the notation of IP version 4, and then I would like to explain about the categories of IP version 4, where it can be divided into two categories, which are classful addressing and classless addressing. IP version 4, IP is an address that identifies the connection of a host to a network. Okay, so each network or each host or each device, if it needs to be connected to the network, it requires IP address. This is like a home address. If you want to identify a house, like a postman, if the postman would like to send a letter to a specific house, so the postman require home address, so that the letter can be delivered to the correct house. So it is similar to the host or device that is connected to a network. To allow the network to forward the packet to the correct destination, it requires IP address. So IP address is an address that identifies the connection of a host to a network. IP version 4 addresses are unique. It must be unique and universal. It can be used to every device and every host, regardless of its manufacturer and its manufacturer. The address space of IPv4 is 2 to the power of 32. Why 32? Because the IP consists of 4 bytes or equal to 32 bits. Now this is an example of IP address of consists of 32 bits. So we have 8 and then 16, 24, 32 in total. The IP address in bits, okay, or equal to 4 billion 4,294,967,296 addresses. Okay, it's huge. It's a lot. Okay, and that is a brief introduction about IP version 4. Okay, now I'm going to explain about the notation. Okay, so the IP address version 4 can be written into representation, and one is in binary notation, the second one in dotted decimal notation. Okay, so first of all, let us have a look on binary notation. Okay, so binary notation, the IP will be displayed as 32 bit or in 4 byte. Okay, so each byte we can call as octet. So each octet referred to as a byte. Okay, so we have 4 octet over here, and the first octet, the second octet, the third octet, the fourth octet. Okay, so in total, the IP address consists of 32 bit or equal to 4 byte. Okay, so the IP, to make it easy, to read, for simplification, the 32-bit form will be written in dotted decimal notation. Why dotted? Because we separate each decimal number by using a dot. Okay. So the second thing is to make it easy to determine the class of the IP. Because in IP version 4 we categorize the IP into two. One is classful, one is classless. So in classful, we divided into 5 classes. 5 classes. Okay. So by representing the IP address into dotted decimal notation, it will be easier to determine the class of the IP address, either class A, B, C, D until E. A, B, C, D, E. Okay, until E. Okay. Okay. Here dotted separate the octet. Dot. Okay. So the range, the range of the IP, if we represent it in decimal, so it is between 0 to 255, or in binary between zeros, all zeros, 8 zeros to 8 1. Okay, this is similar when you convert 0 0 0 8 0. This is in binary. You convert in decimal, it is equal to 0. Okay, 1 1 1 1 1 1 8 ones. If you convert in decimal, it is equal to 2 5 5. And how to get to 5 5? So you need to know the operation. And this is 2 to the power of 0. Okay, this is 2 to the power of 1. Until 2 to the power of 7. Okay, so we have 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 7, 2 to the power of 8. 2 to the power of 0, 1, 2, 3, 4, 5, 6, 7. 2 to the power of 7. It's not 8. So if you calculate this, 2 to the power of 0 times 1 is 1. And because 2 to the power of 0 is 1. 2 to the power of 2, 2 times 1 is 2. And then you add them together. Okay, here is 2 to the power of 2, 4 times 1 is 4. Okay, plus, then 2 to the power of 3, 8 times 1 is 8. Plus 16. Okay, plus 32 plus 64, and lastly plus 2 to the power of 7, 1 to 8. So the total is 255. So the range, if you want to write it in binary, so it must be between all zeros, 8 zeros to 8 1. Or if you want to represent it in decimal, from 0 to 255. So if you have an address that is given like this, 192 dot 16 dot 3 dot 0. So is this a valid IP address? So you need to check whether each decimal within the range 0 to 255. If yes, then this is a valid address. Okay, so let's say you are given this one, 128 11 3 31. So check all decimal number. If it is in within the range, then it is a valid IP address. So if you are given let's say 192.2.3.256. So is this a valid IP? So check 192 within 0 to 255. 2 within that range. 3 within that range. 255, how about 255? 255 is greater than 255 and 256 is greater than 255. So this is out of the range, and this one out of the range. So this is invalid IP. Okay, so this is an example. I think you can have a look. So this is the process of conversion, change from binary to dotted decimal. And this is from dotted decimal to binary. Okay, I hope you know how to convert it. Okay, you can use you can convert this one. You can convert from here to here. You can use your own calculator. Okay, you can calculate it manually as well. Okay, done for notation. Now we are going to the next topic, the next point in this chapter, which is classful addressing. So IP version 4 can be divided into classful and classless, and this is classful. Means that the IP will be divided into classes. Okay, so IPv4 use the concept of classes called classful. So the class will be divided into 5 classes, A until E. Okay, so how to differentiate the classes? So we can have a look on the bit representation. Look at the first 4 bit in the first octet, and the first 4 bit in the first octet. Okay, so this is the key point. So look at the first 4 bit in the first octet, because you are given 4 octet. Each IP will be represented in 4 octets. So look at the first octet. First octet, the first 4 bit. Okay, so if you want to identify class A, the first bit. So look at the first octet. 1, 2, 3, 4, 5, 6, 7, 8. So you just need to consider the first 4 bit. If the first bit in the first 4 bit is 0, then it is class A. For example, you are given 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, look at the first 4 bit. If the first bit is 0, and this is equal to 0 in decimal. So if the first bit in the first 4 bit is 0, then it is class A. Okay, so class B. If the first bit is 1, the second bit is 0. Something like you have 1, 0, 0, 0, 0, 0, 0, 0, or equal to 1 to 8. 1 to 8. So look at the first 4 bit. If the first bit is 0, the first bit is 1, the second bit is 0, then it is class B. Easy. And that's the way how we identify the class of the IP address. If you like to determine if the IP in class C So look at the first bit. If the first bit is 1, the second bit is 1, the third bit is 0, then it is class C. Class D, first bit is 1, second bit is 1, third bit is 1, the fourth bit is 0, then it is class D. For example, we are given 1, 1, 1, 0, 0, 0, 0, 0. This is equal to 128 plus 64 plus 32 equal to 224. 128 plus 64 is hang on a minute, it's not 224. 128 plus 64 is 2 plus 1, 9, 192 and 192. So plus the next one is 32. Yes, it is 224. 2 is 4. 9, 3, 12 plus 1 is 224. Okay. So if the first bit 1, the second bit is 1, the third bit is 1, the fourth bit is 0. So it is class D. It is class D. If all first bit are 1, let's say 1, 1, 1, 1, 0, 0, 0, 0, the first 4 bit are 1, then it is class E. That's the way how we identify the class of the IP if they are given in binary notation. Okay, this is the process, so the flow. Okay, so you have a decision over here. Start. So check whether the first bit is 1 or 0. If 0, then class A. Easy. And then if 1, then go to the next decision. Okay. If the second bit is 0, then B. If not, go to the third condition. If the third bit is 0, then class C. If not, then go to the fourth. If the fourth bit is 0, then class D. If not, class E. And that is the way how we determine the class of the address. Or you can look at the range of the decimal and dotted decimal notation. So class A must be between 0 to 127. 0 to 127. Okay. So if you are given the address 10 dot, so what is the class of this 10 dot? And this is class A because it is within this range. 10.0.0.0. This is class A. Okay. So if you are given 192 .168 .3.2, this is in which class? 192 within this range 192 to 3. So this is class C. Okay, this is an example by using binary notation. So if you want to determine, look at the first octet, the first 4 bit, then check the first bit is 0, then class A. Look at the first octet, the first 4 bit. If all ones, so this is class E. Easy, isn't it? And now, if the address is given in dotted decimal notation 227, so you need to remember the range 0 to 127. That is class A. 128 to 192, 191, class B. 192 to 223, class C. 224 to 251, class class D. 252.2.2.5.5 class E. Okay, so 227 class D. Class D over here. Class D. 252 is over here. Class E. Oh, 239. Sorry. So 224 to 239 is over here. 239. 240. Hang on a minute. Let me erase this one. Okay, I forgot the range. So 240. This is 239. And this is 240. And the range. Okay, class E. Okay, 134 is class B, is over here. Okay, E. Okay, so we have in classful addressing, the address will be divided into two portion. One is we call as netid, that identify the network, which network the addresses belong. Host ID, identify which host the address is assigned. Okay, so in class A, the first octet is reserved. The first octet is assigned with netid. The rest will be host, will be assigned to the host. Okay, so class A has one netid, 3 host ID. So it's over here. One netid, 3 for host ID. 3 octet for host ID. Class B, the first 2 octet are assigned with netid. And this is net and netid. And the last 2 octet for host. Class C, the first 3 octet will be assigned as the netid, net. And the last octet will be assigned to the host. Okay, but not class D and class E, because this is a special class. It is used for other purposes, like multicast and for research purposes. Okay, so this is a proper way how we identify the net and host ID. So part of the net will be used for class type. In the class A, the first 4 bit will be used to identify the class of the IP address. And this is part of the netid portion. Okay. Okay. So this is the how we differentiate. Netid, yellow in color means net. White in color means host. So class A, only the first byte that will be assigned to net. The rest will be assigned to the host. Okay, this is in binary and this is in dotted decimal notation. Okay, this is an example. If you are given an address 192.168.2.1, so you need to identify the class first. First step is identifying the class, because from the class we know and we can determine the net and host. Okay, net or host. Okay, so let's look at this example. 192.168.2.1. 192 within the range of class C. Okay, so we identify the class of the address, so it is class C. And because it is class C, we know that class C, the first 3 octet net, the last octet host. So based on this, we know that 192.168.2 are assigned for the net, and dot 1 is for host. So 192.168.2 is net ID, and dot 1 is host ID. That's the way how we identify the net and host portion for a given IP address. For okay, the next, you are given 60.5.6.244. Okay, so let's look at the first octet and then identify the class. 60 is within 0 to 1 to 7. So this is class A. We know that class A, only the first octet will be assigned to the net ID. The rest will be host. Okay, so that 60 is the net ID. .5.6.244 is host ID. Okay, now, because we have already know how to identify the net and host ID. Now we are going to determine the class and the block size. The class and the block size. So the block size. So each class is divided into fixed number of block. Okay, each block having a fixed size. Okay, so let's look at example over here. Class A. Class A contain 1 to 8 block. Because why? Because class A is between 0 to 1 to 7. Okay, so in total we have 1 to 8 number of block. Okay, so and then the block size. Okay, you need to identify the if you want to identify the block size, you need to look at the host ID portion. So class A, okay, as we know that class A, only the first octet will be assigned to the host, to the net. The last 3 octet will be assigned to the host. Okay, so if you want to know the block size, you can calculate the number of bit at the host portion equal to 24 for bit. This is net, this is host. Okay, so if you want to identify the block size, you calculate 2 to the power of 24, which is equal to 16,777,216. Okay, so if you want to identify the block size in class C, okay, so you need to determine the host portion first. And in class C, the first 3 octet represent net, and the last octet represent host. Okay, so if you want to identify the block size of class C, so it is equal to 2 to the power of how many bit over here? 8, isn't it? 2 to the power of 8 equal to 2, 5, 6. Okay. Okay, now let's look at block in class A. Okay. So block in class A is from 0 to 1 to 7 based on the range class A. So from net ID 0 to net ID 1 to 7. Okay, so this is class A. Class A block. Okay, so we have block in total we have 1 to 8 from block 0 until 1 to 7. So in total 1 to 8. Okay, so block 0 is from 0.0.0 until 0.255.255.255. The first octet represent netid, because this is class A, and the first octet must be the same, and the first octet must be the same. This is block 127. So each block has huge number of addresses, as we have discussed before. Okay. In class A, there are two special blocks, block 0 and block 127. It cannot be assigned to any network, because it is special block. Okay. The yellow one is the valid block. So start from 1.0 until 126.0, and this is valid block, that can be assigned to any network. Okay, so let's say if we pick up one block 73.0.0.0, okay, until this is the first address and this is the last address. Okay, the first address is the network address. It cannot be assigned to any host in the network. The last address is broadcast, and it cannot be assigned to any host, any host in the network. Okay, so the valid address that can be assigned to the host is between .1 until 73.255.255.254. Okay, and this is the example of class A. Now let's look at class B. Class B. Okay, class B, we can the netid, the what you call it, the range is between 128 to 191. Okay, 191, the range of class B. So in class B, the first two octet net, the first two octet net. So you have a lot of combination, 128.0, and then until 128.255. So you have a lot of block. You have a lot of number of block. Okay, so it's about it's more than 16,000 number of block in class B that you can have, because the first two octet represent netid, so you can have many combination. So this is the block 128.0, and the first two octet must be similar because this is class B, and this is class B. Okay, class B. Host can be varies, and the first two octet must be similar. Okay, so in class B we can use all block, and there is no restriction, compared to class A. In class A, two block cannot be used to be assigned to any network, and because it is special block, class 0 and class 127, block 0 and block 127. Okay, so 180, we pick one example over here, one block 180.8.0.0 until 180.8.255.255, and this is the maximum number that can be put in the host ID, all ones in binary. Okay, so this example, so this is the first address and network address we assign as, we identify this as network address. The last address is the broadcast, so the valid is between is these are the valid address that can be assigned to the host in the network. So it's over here, the number of block in total 16,000. Each block contains 65,000 number of addresses. It's huge. Class C, and this is the smallest, block size, because if we have a look, the first three octet in class C will represent net, the last octet will represent host. So that's why the size of the block is very small, because only 8 bit here at the host portion. 2 to the power of 8 equal to 256. So each block in class C contain a small number of addresses. But from class C we have 8 we have 3 octet which represent netid. So we can have a lot of block. We can have a lot of block. So number of block is about 2 million. So the range is between class C the range is between 192 to 223. So we can have more combination over here. So pick one example. You can use all the block in class C. Okay, one example, 200.11.8. This is the netid. Netid must be the same, so that they are in the same network. Sorry, over here. Okay, one example. This is the first address, the network address. This is the last address. Here the host is maximum 255, and the valid address that can be assigned to the host. Okay, so we have discussed this before. Network address is the first address, isn't it? The first address is the network address. So network address is the one that is assigned to organization. Okay, so network address. So this is an organization. So how to identify this organization based on the network address? This is different organization. So how to identify this organization based on the network address? Different class. So class A, only the first octet, only the first octet represent net. Host, all will be 0. That is to identify the first address in the network. So in class B, the first 2 octet net host all zeros, and that will be the first address, and the first address will be the network address. So it's over here. Host all zeros. Net can be any number, but it depends on the class of the address. Okay. So let's look at this example, 23.56.7.91. So if you want to identify the network address, you need to identify the portion of net ID and host ID. Okay, to identify the net ID and host ID, you need to identify first the class of the address. Class. Okay, so go back to the question over here. So first you need to identify the class. 23 is within 0 to 127. So this is class A. Okay, done. Okay, because this is class A, so you can divide it into net and host. Okay, because this is class A, the first octet net, the rest host. Okay, so when you have identified the net and host, you just change host all zeros. So now it becomes 23 remain dot 0 dot 0 dot 0 is the network address. So this is the answer. Easy, isn't it? Okay, now broadcast. Broadcast refer to the ability to address a message that is broadcast to all station or hosts in the network. Used for broadcast to all station in the network. So if the message okay, will be given with the broadcast address, so it will be forward to every host in the network. This is one network, this is another network. Okay, so how to identify the host the broadcast address? You need to identify net and host, because broadcast host all one. Netid can be any number. Host just change to all one. That will be the broadcast. For example, class A, 1 to 3 is class A. Host all ones. So it become 255, 255, 255. Okay, and so on. Okay, let's look at this example. 128.56.7.91. Okay, so how to identify the broadcast? Okay, not network. This is wrong. Broadcast and broadcast. Okay, so first of all, let's identify the class first. And 128 is class B. Okay, we know that class B divide, okay, the first 2 octet net, the last 2 octet host. Okay, so since the last 2 octet host, so to identify the broadcast, we just change host to all ones. So it becomes 128.56.255.255. Okay, easy, isn't it? So this is the answer. Okay, masking. In classful addressing, we can use mask or default mask to determine the class of the address as well. So let's say you are given 10.0.0.0/8. 8 means 8 ones. 1 1 1 1 1 1 1 1 0, all zeros, all zeros over here. So this is the representation of /8. So this is equal to 255.0.0.0. Okay, so this will identify net host. So if one net 3 hosts, then this is class A. Okay, and that's the way how we identify the class of the address by using default mask. /8 class A, /16 class B, because the first, and for /16 the first 2 octet contain 1. So this represent net. Class B must be like this. So this is class B. So /24 class C. Okay, so let's look at this example. A router outside the organization receive a packet with destination address 190.214.7.91. And this is class B, isn't it? And because the range is between 128 to 191. Class B. So how it's find the network address route? Network address. So you can use the default mask. Okay, 190.214.7.91. Okay, you use AND operation. The router will use AND operation with the default mask. So the default, this is class B. So the default mask of class B is /16 or 255.255.0.0. Use AND operation, AND. So AND you need to convert in binary. Okay, or you can just simply 190 AND with 255 in binary. This must be in binary. So the answer is 190. 240, 255 all ones. So 240. 0 and 7 is 0 0 0 0. Okay, 0 1 1 1. You end with all zeros. 0 0 0 0 0 0 0 0 0 2 4 6 8. Okay, there is no 0 over here. Okay, so you will get 0 over here and 0 over here. So you can identify the network address by using AND operation with the default mask. Okay, we have done with what we call it, default mask. Now we are going to discuss about subnetting and the concept of subnetting. So what is subnetting? As I mentioned before, and subnetting used in classful addressing, only in classful, introduced to divide a large block in class A and B into several contiguous group, smaller group. So let's say you have a network of class B. Okay, you know that class B, in each block or in each network of class B consists of 16 and more than 16,000. Hang on a minute, it's not 16,000, 64,000, and the size of the block is 64, more than 64,000 addresses. So huge, isn't it? Is there any problem with a large size of network? Yes, the answer is yes. What is the issue, or what is the problem for a large network? First is the network congestion. The second thing is security issues. So how to solve that problem? We use subnetting. How subnetting is work? So it divides the large network into several contiguous subnetwork. So we can divide into 2, into 4 subnetwork. And when we have divided into several subnetwork, so they are in different network. And let's say this is subnet 1, subnet 2, and subnet 3, subnet 4. You divide into 4 subnet. So they are in different. When you divide it in from a single network, this is the original network from a single network. Okay, so let's say you have two hosts here. So when they are in the same network, they can communicate without the use of a router, and they can communicate directly. But when you divide into several subnetwork, when you do subnetting, so they now are in different networks. So they require a router to communicate one another. And when you done the subnetting, now they need to communicate through a router because they are in different network. Okay, that is subnetting. And what is the implication after subnetting? First, you can have a smaller size of network. Okay, the second thing is you need to communicate through a router. Communicate through a router to if you want to communicate across different networks, so you need to communicate through a router. But if you want to communicate within your subnetwork, you don't need this router. Okay, so what is happening, how the subnetting is work, what changes are made during the subnetting process? We increase the number of 1 in subnet mask. Okay, for example, default class A mask is 255. Okay, so when you do subnetting, you increase the number of 1s in subnet mask. Okay, it becomes something like this. So 255.255.0.0, and you increase the number of 1. For example, this is the default mask of class A. 0.0.0. Okay, now this is the default. Okay, when you do subnetting, when you divide the network into, let's say, 2 and 4 subnet, so you increase the number of 1s in the subnet mask. For example, you add and you increase the number of 1 over here. 0, 0, 0, 0, 0, 0. You increase 2, for example. You can increase 1, you increase 2, you increase 3. Okay, it depends on how many subnet, how many subnet do you want to create from a single network. If you want to divide the network into 2, so you increase 1 bit. If you want to divide into 4, so you increase 2 bit. If you want to divide into 8, 1, 2, 3, 4, and 5, 6, 7, 8. So you need to increase 3 bit at the subnet mask. Okay, this is the example. So you increase, this is without subnetting, this is with subnetting. So you increase the subnet mask and you increase the number of 1 in subnet mask. Means that you borrow some bit from the host portion, you change some bit at the host portion, some bit at the originally, all bit in the last octet are assigned to the host, but you take some bit from the host portion to become subnet ID. That is subnetting. Okay. Supernetting. Supernetting is applicable to class C, because supernetting, when we have a small size of network, we can create a larger one by combining several blocks to have a bigger block. That is implemented in class C. How? By reducing the bit 1 in subnet mask. Here, over here, this is the default mask of class C. Okay, so you reduce 2, for example, so it become like this. This is we call as supernetting. Okay, so now we are done with classful addressing. So let's discuss with classless addressing. Okay, in classless addressing, there is no class. There is no class. No class anymore. As we know that classful addressing, a large part of the available addresses are wasted. So classful addressing, which is almost obsolete, is replaced with classless addressing. There is no class to avoid address depletion. Okay, this is okay, hang on a minute, let me explain. Okay, here there is in the address block, and this is in classless, there is no fixed range. Let's say 0 to 1 to 7, and that is class A. So there is no fixed range. Okay, size of the block varies based on the nature and size of entity. So let's say you want to construct a small network which consists of 5 hosts. So you will assign, you will provide the IP addressing scheme so that you can produce the number of address that close to the network requirement. For example, if the network require 5, so you can provide the minimum must be 8. Why 8? Because 5 is for the host, 1 is for network address, 1 is for broadcast address. Each network must contain network address, 1 broadcast address, and 1 gateway. Gateway, so that this network can communicate with other network. So 5 plus 3. Why 3? As I mentioned here. Okay, so 8. So the minimum address to be assigned to this network is 8. So we are not given class C address because class C address contain 256 addresses. Even though however, this network require only 8 addresses. So if you subtract with 8 address, so you can see how many address that will be wasted. So this is 16.8. 248 addresses will be wasted if you assign with class C address to this network. So we are not using classful addresses. Classful address. We are going to use classless. So how to do this? We need to follow this condition. The address must be contiguous. The address must be power of 2. So this is can be equal to 2 to the power of what? 2 to the power of 3. See, equal to 8. Must be in terms of 2 to the power of. So you can assign the number of address in terms of 2 to the power of, and the total number of address must be 2 to the power of. The address and the mask and the address or the slash notation completely define the whole block. So we use slash notation. For example, 192 dot 168 dot 3 dot 32 minus 3 32 minus 3 29 dot 0 slash 29, for example. Okay, so this slash notation will identify the block size, the block size. Okay, the block size. Okay, so it's quite easy to identify the block, the whole block. So we need to have a look on the information over here, the slash notation, because this slash notation will completely define the whole block. And for this example, we know that this block will contain how many addresses. If you want to know, so you just do like this. Total bit 32. Because this identify the net. We know that the slash notation will identify the net. So here it means that 29 ones. 1, 1, 1, 1, and there are 29. Okay, 29 1 means how many bit left for the host? 3 bit, isn't it? 3 bit. So 32 minus 29 equal to 3 bit. So what is the block size? 2 to the power of 3 equal to 8. So the total number of addresses that can be provided by this IP address is 8. So the block size is 8. You contain 8 addresses. Okay, I think I skip for this one. Okay. Okay, this one. Let's look at this example. Find the network and broadcast address for host with when address an address 192.168.3.20/28. So we use this information to determine the network address and broadcast address. So by using this information, you can determine net and host. We are not using class. We are using this information to determine net and host. So this is very important part in IP addressing. So over here we know that 28 28 means 8 16 24. So here all ones, total 24. The first 3 octet. So now we have 4 over here. The remaining bit 4. 24 plus 4 become 28. Okay, or you can use 32 because the total bit is 32 minus 28 ones equal to what? Equal to 4, isn't it? Equal to 4. So it means that there is another 4 bit over here, and there is another 4 bit, and the last octet will be divided into 2 parts, because total is 8, the last octet. Now the first 4 bit will become net because of the total is 28, and the last 4 bit over here will become host. So 4-bit at host over here. The last 4-bit host. Okay, so you can represent it like this. This is /28, or equal to this one. Okay, so based on this, you can determine the network address by using AND operation. AND operation. You AND with you AND 192.168.3.20 with /28. This is /28. So you AND 192 AND with 111 over here is 192. 168 AND with all ones over here, 168. 3 AND with all ones over here, 3. Okay, the last one over here, 20. So 20 in binary is you got 8 over here, 16. 16. Sorry. This is 4. 4 plus 16. So 16 plus 4 equal to 28, isn't it? 20. 16 plus 4 equal to 20. So that's 20. So this is equal to 0, 0, 0, 1, 0, 1, 0, 0, 2, 4, 6, 8. This one, isn't it? This is 32, 64. Okay. So end with 1, 1, 1, 1, 0, 0, 0, 0. So what is the answer? 0, 1, n it will be 0. 0, 1, 0, and if the bit is different, then it's 0. 0, 1, 0, 1, 1, 1, 0, 0, 0, 1, 0, 0, 0, 0, 0, you end this one, 0, 0, 0. So this is the answer. Or if you write it in decimal, the answer is 16. So this is the network address. So the network address is 192.168.3.16/28. That is network address. Okay, broadcast /23. So you just change the host portion to become all ones. And this is 16, something like this, because this is the it will be divided like this. This is net and this is host. Okay, host all zeros for network address, broadcast all ones. That's why you got, when you calculate, you got 23. 16 plus 15, isn't it? I think it's not 23. Hang on a minute. Yeah, okay. No, 23. Why do you get 23? Because 16. Okay, 16 plus 15. It's supposed to be 31. 16, 17, 18, 19, 91, 21, 22, 23, 27. So I think this is wrong. It's not 23. It is 31. 31.31, because here 16. Okay, this is 8421, and this is 15 plus 16 over here, so 31. It's supposed to be 31, 31. Okay. Okay, I think that's all for today. That's all for today. Okay, that's the end to today's session, to this chapter. Okay, I hope that okay, you got the idea what is the IP version 4 and the notation of the IP version 4, the classful addressing and the classless addressing in IP version 4. Okay, that's all. Okay, thank you very much, and assalamu alaikum.